Hi students, we are starting to the new topic, that is types of chemical reactions. For studying these types of chemical reactions, the basic requirement was how to write a chemical equation. What do you mean by a chemical equation? Balancing of a chemical equation, etc. In the balancing part itself, the balanced chemical equation again we can classify it into two, that is a complete balanced chemical equation and incomplete balanced chemical equation. What is that? Incomplete balanced chemical equation and complete balanced chemical equation. It means if the physical state of each and every species involved in the reaction is mentioned, then we can say it is a complete balanced chemical equation. That means if any of the species in the solid state, we should mention its physical state as small s after its symbol. If it is liquid, we should write L for its symbol. If it is gas, we should represent G as its symbol. If it is aqueous, then you should write AQ as its symbol. If these physical states also you are mentioning in the balanced chemical equation, then we can say it is a complete balanced chemical equation. Now we can move to our chemical reactions, different types. They are combination, decomposition, displacement and double displacement. These are the four different types of chemical reaction we should discuss here. One more is that is a redox reaction. The redox reaction we can study in a different topic, but even though I am including that redox reaction also here, redox reactions. So, combination, decomposition, displacement, double displacement and redox. So, here I am discussing about a combination reaction. For studying a combination reaction, I will represent a small diagram here. From that diagram, you should conclude what is a combination reaction. Here, just consider this is a small worm. Okay, small worm. And there is a chip. Okay, and now this chick swallowed this worm. Now the worm is inside the stomach. This is the representation of a combination reaction. I hope you may understand what it is a combination reaction. There are two separate components and now it converted into one single unit, one single component. That means we can say one or more, two or more reactants, combine to form a single product. If two or more reactants combine to form single product, two or more reactants combine to form a single product, then it is known as a combination reaction. This is the reactant number 1 and this is the reactant number 2. Two reactants. Now it converted into what? A single unit. So only one product. This is known as a combination reaction. I think or I hope you may able to connect this picture with the combination reaction. Now, the second one is a decomposition reaction. Decomposition. So, the second one, decomposition. Decomposition reaction also I am representing with a schematic or symbolic representation like this. An eggshell. Inside the eggshell there is a chip. And when the shell is breaking down, what you will be getting, tell me? It will be a shell separate along with that the chip will be outside. I hope you may understand what is a combination. What can be the combination reaction? Tell me. Here only one reactant. That one reactant is converted into, this is product number 1, this is product number 2, this is product number 3. That means P1 plus P2 plus P3 you are getting. So how can you define a decomposition reaction? Decomposition means one reactant converted to two or more products. One reactant is converted into 2 or more products. Reactant will be 1 and the product will be 2 or more. Such reactions are known as decomposition reaction. So, in the beginning there is a single unit, the eggshell, inside the chick will be there. Once it breaks, it can convert it into eggshells, 2 pieces of eggshell and a chick separate. That means the one reactant unit is converted into 2 or more products. Such reactions are known as decomposition reaction. When we are discussing the decomposition reaction, there are 3 different types of decomposition reactions are possible. The first type of decomposition reaction is thermal decomposition. Thermal decomposition. Thermal decomposition means, from the word itself it may be clear for you. Therm means heat. So, if the decomposition reaction takes place by heating, due to heating, if a decomposition is taking place, then it is known as a thermal decomposition. So, decomposition by heating. Decomposition by heating is known as thermal decomposition. So, here let us consider, I am taking an example, CaCO3, calcium carbonate. How I got the formula of calcium carbonate? Calcium and carbonate. Calcium is in group 2, valency 2, carbonate valency 2, crossover, simplest ratio, crossover, calcium carbonate. And calcium carbonate on heating. So heating can be represented with a triangle above the arrow mark. If a triangle is there above the arrow mark, means heat is provided. And you will be getting calcium oxide and carbon dioxide. So calcium oxide, I don't know the molecular formula, so I am writing calcium and oxygen. Calcium in group 2 valency 2, oxygen is in valence group 6 or 16. So group 6 or 16 valency 2. So cancel 1 and 1, cross over the valency. The formula is calcium oxide and carbon dioxide. Here only one reactant, and the reactant is converted into two products, P1 and P2. Here calcium is 1, calcium is 1, carbon is 1, carbon is 1, oxygen 2 plus 1, 3, here also 3. It is a balanced chemical equation. So this is the example of a thermal decomposition reaction. Now the decomposition by heating, it can be termed it as a thermal decomposition reaction. Then second one is electrolytic decomposition. Electrolytic decomposition. From the word itself, it is very clear. What is electrolytic decomposition? What do you mean by electrolytic? Electrolytic means by passing electricity. So we can write decomposition by passing electricity. Passing electricity. If decomposition takes place, we can term it as a electrolytic decomposition. For example, we can take water, impure water we are taking, and the impure, because the pure water is not allowing the electricity to pass through it. So you are taking impure water by adding little amount of acid or a salt or something. And if you are passing electricity, there is no symbol for electricity. You have to write electricity above the arrow mark, and you will be getting hydrogen gas and oxygen gas. Here we can try to balance the chemical equation. The greater number will be hydrogen. Hydrogen is 2. Here also 2, it is balanced. In this case, oxygen, there is 2. Here only 1. You cannot put a 2 here. That is wrong, because water symbol is H2O. So I am putting 2 here. So oxygen is 2. Here also oxygen is 2. It is balanced. Now the number of hydrogen is changing. 2 2s are 4. 4 hydrogen. So you can write a 2 here. So if you are putting 2, 2 2s are 4. Hydrogen is balanced. So here also a single reactant and converted into product number 1 and product number 2. So if a single reactant is converted into 2 or more products, then it is known as electrolytic decomposition by passing electricity. If by passing heat, if decomposition is taking place, then it is known as thermal decomposition. So decomposition reaction means one reactant is converted into 2 or more products. Here one more is there, that is photolytic decomposition. That photolytic decomposition we can discuss in the next session.